Again, a very good morning, students. We will discuss today the fuel systems of diesel engines. I am Shivnandan Luthra from Government Polytechnic College, Amritsar, and I am working in a mechanical department. Before coming to our main topic, I will like to discuss about the introduction of IC engines. See, IC engine stand for internal combustion engine. This is one of its preview. This is the 3 cylinder shown over here. The 4 cylinders are there, 3 are in the full preview, and the fourth one is shown. Fourth one is shown with a sectioned piston. But internal combustion engine needs fuel, ignition and compression in order to run. The fuel is having some calorific value which helps to ignite. Before ignition of fuel, it is compressed in a very specific amount. Basically, the IC engines are of given types. Mainly, we are concerned with the 4-stroke gasoline engines. Beforehand, we have also used the 2-stroke engines. And depending upon the fuel used, we can change it. We can classify it in the diesel engines or petrol engines or any other non-conventional material also. The IC engines are also in the rotary engines availability, as well as the steam engines are also there. Configuration of engines. Inline engines, the cylinders are arranged in a line, in a single bank. All the cylinders, as we see generally in our engines, we are having inline engines. In our cars, in Maruti car, in Swift or in any other make of Indian car, we are generally using the inline engines. Next is the V engines. In the sports car, basically what happens, we need more power and more efficiency, but the space is very low. So, we use this arrangement as shown in the figure. I think this is a self-explanatory figure, as in the inline engine there are 4 cylinders, and see the space occupied by this type of engine, inline one, and V engine one is almost the same. But in the case of V engines, there are 6 cylinders. They are inclined to each other at some angle. And third type is of flat engines. The cylinders are arranged in 2 banks of on opposite sides of the engine. This is the arrangement. This is almost an obsolete arrangement we don't use in these days. Various parts of engines. Various parts are the valve rods, return springs, and the camshafts. Exhaust valve lets the exhaust escape from the combustion chamber. Generally, the diameter is smaller than intake valve. Intake valve lets the air of air-fuel mixture to enter the combustion chamber. Diameter is larger than the exhaust valve. These are the indication markers. Minimum types of per cylinder. Engine. Valve springs keeps the valves closed. As in this arrangement it is shown over here, the springs are used to close the valves. Next, the valve lifters ride the cam lobe and helps in opening the valves. These are the cam lobes. Different arrangement of valves and camshaft. These are shown over here. In the first arrangement, directly we are using the generator sets, we are also using the rocker arms. In the high engines, in having the more CC, we are using the rocker arms. Camshaft. The camshaft that has intake and exhaust cam for operating the valves. These are the camshafts. See, there are the 4 cams shown on the one shaft. Having each shaft there is having a separate, but in actual practice what happens, if there are 4 cylinders in an engine, then on the camshaft there would be 8 cams, 2 each for the cylinder. Cam lobe changes the rotary motion into reciprocating motion. As we have seen before, the cam lobe, cam lobe changes the rotary motion into reciprocating motion. See, this is the shown. The cam lobe is changing its reciprocatory motion to the rotary motion to the reciprocating motion. Spark plug. This is the component which ignites the fuel. It provides the means of ignition when the gasoline or our fuel mixture with air enters the piston, enters the engine's cylinder. Engine piston is at the end of the compression stroke, close to the top dead center. Generally the spark plugs are close to the top dead centers. The difference between a hot and cold spark plug. Generally there are two types of spark plugs. Number 1 is hot plug, number 2 is cold plug. The difference between a hot and cold spark plug is that the ceramic tip is longer on the hotter plug. As you must have seen, the students, as you must have seen the spark plug, what happens, there is a white coating of ceramic on which there is generally written MICO. That ceramic tip is longer in the case of hot plug, as it is shown in figure. This is the arrangement of pistons and valves. A movable part fitted into the cylinder which can receive and transmit power. The piston is a reciprocating motion. The piston is in reciprocating motion, and though the connecting rod forces the crankshaft to rotate. There are various kinds of valves shown, as you can see. One is intake valve and another is outstroke valve or exhaust valve. The fuel and air, that is the mixture, the combustible mixture is coming inside, and when it gets combustible, it is going out through the exhaust valve. Cylinder head. This is a block over the main cylinder. Part that covers the enclosed cylinder. It contains cooling fins and water jackets and the valves. Some engines contain the camshaft in the cylinder head. This is an engine block in which all the parts distributed, as I have shown or told you have beforehand, are inside it. Foundation of the engine and contains piston, crankshaft, cylinder timing and sprockets, and sometimes the camshaft. Connecting rod, or sometimes known as con rod also. This is the placement of our connecting rod. There is one big end and another is small end. Big end is on the lower side and the small end is on the piston side. There is a gudgeon pin inside it, and we are converting the piston's reciprocating motion to the camshaft's rotary motion with the help of connecting rod. Attaches piston wrist pin, that is wrist pin, also small end of the crankshaft pin, and the connecting rod caps. This is the partition view of connecting rod, piston and pin. The piston pin is also known as gudgeon pin. Crankshaft. The crankshaft, this is the one of the crankshafts shown, and it is the 3-cylinder engine crankshaft. See, there is a peripheral area which is very fine, so we can convert, we can judge it how many terminals of it having. Converts up and down the reciprocating motion into the circular or rotary motion. This is shown the complete arrangement. In the 4 cylinders engine, there are 4 pistons individually shown over here, and the various arrangements are also shown. Engine's main component known as piston is shown in this particular case. Piston rings are 4 piston rings are there and shown in this case. For 4-stroke, 3 rings, top 2 having are the compression rings, ceilings and the compression pressure in the cylinder. Above the piston and below the TDC or IDC, that is inner dead center or top dead center. In the case of horizontal and vertical engine, we can classify it. The compression should remain inside the cylinder. The compression should remain inside the cylinder, and which would like to compress the piston as well as it will generate the energy to transmit further. 2-stroke, in the case of 2-stroke engines, there are 2 rings, both rings are compression rings. And the very important part known as flywheel. Flywheel is that particular part which stores or becomes the storage media of the intermittent energy coming from the pistons. It is attached to the crankshaft. Reduces the vibration because it stores the energy. It works just like a capacitor. Cools the engine in the case of air cooled. As you may have seen in the Bajaj scooter, there is a fan rotating on the right side, on the kick area side. That particular fan is not just acting as a fan, it is the flywheel. This is shown over here. This is of an Activa, Honda Activa part flywheel, used during the initial startup also. Transfers the power from engine to drivetrain. This is the whole engine. On the upper side, these are the camshafts. This is 1 and 7. 6 number is shown as the cam. These are the piston 1, 2, 3 and 4. And these are the gear trains. These are the valves 1, 2, each having 2 valves. See, there are the 2 types of valves also. Number 1 is, this is a single valve case. 1 valve is for intake and 1 valve is for exhaust. If there would be 2 valves for each case, 2 valves for intake and 2 valves for exhaust, then we can say that it is twin cam valve. Fuel systems, various used: gasoline, diesel, liquid propane and alternative fuels. And we will deal mainly with the common rail fuel injection system, also known as CRDI. Demand, what is the basic need of CRDI engine? That is the low fuel consumption, low pollutant emissions, quiet running engines, and improved engine performance. As well as the fuel consumption is concerned, this generally gets reduced in the case of 4-stroke. See, the power stroke is coming every time after 2 revolutions of crankshaft. It is very obvious that the fuel consumption will be reduced, and generally the diesel is used in the 4-stroke cases. Another case is low pollutant emissions. This factor comes from the two gainings that mostly such engines are low RPM engine. That is, these engines are running on 2500 RPM maximum, or running at 4000 RPM maximum. So these are low RPM engines. This factor also reduces the pollution emissions. It is quite obvious that these are heavier engines but running at low RPM, so they are generally quiet. And it is also very natural that the engine performance will be improved, because it generally works at low RPM as well as in a better working conditions also. Now getting inside the CRDI system, or common rail fuel injection system, and its function. Firstly, the common rail fuel injection system provides the diesel engine with fuel, generates the high pressure needed for the fuel injection inside the cylinder, and distribute the fuel to the individual cylinders. The common rail fuel injection system injects precisely the correct amount of fuel at exactly the right moment in the time. This is a highly needed, precisely actioned function required inside the cylinder. Not just the amount of fuel is important, but its timing is the most important. The right amount of fuel, the right time at which it is injected is very important for the proper functioning of engine. The working of engine is also based on this system, as the working media, that is CRDI system, will the basic function of full engine working. This system also works as an accumulator in the case of injection. The fuel is firstly accumulated inside the engine system of common rail, then it is further supplied to the individual or as per requirement. Sub-functions of CRFI system, common rail fuel injection system. Firstly, there is a low pressure circuit, there is a high pressure circuit, and a ECU with sensors. ECU stands for electronic control unit. The common rail sub-functions, number 1 was low pressure circuit. The low pressure circuit comprises of fuel tank, pre-supply pump, fuel filter, and the respective connections lines. As we can see, the fuel is going from fuel tank to the pre-supply pump. From this, it is directly supplied with the common pipeline known as common rail. The common pipeline known as the common rail to the each injector as shown over here. I am taking a little bit more time for each slide for the students to analyze the figure. Then the low pressure circuit. The low pressure circuit is responsible for transporting the fuel to the high pressure circuit. As you are watching the fuel, after the fuel filter from the pre-supply pump, there is a circuit on the lower left section. Below the fuel filter there is a pipeline going inside. The high pressure circuit sub-functions. High pressure circuit pressure pumps with the pressure control valves. There is a rail pressure sensor, that is common rail. There is a main pipeline sensor of pressure which senses the pressure requirement, and it can accordingly vary also. The high pressure accumulator with the rail pressure sensor. Injectors and the respective high pressure connection lines. Now the high pressure area is connected to the further injectors, whereas the low pressure area was just connected to the rail, and the high pressure pump delivers the requirement of fuel in the individual cylinder. It is the responsibility of high pressure circuit to generate a constant unvarying high pressure in the high pressure accumulator, that is the common rail, and to inject the fuel through the injectors into the engine's combustion chamber. Now the common rail sub-functions. Electronically controlled unit and sensors. The common rail electronic control unit evaluates the signal from the following sensors: crankshaft, speed sensor, and the crankshaft sensor, accelerator, pedal travel sensor. The electronic control unit receives the various kinds of signals of the engine speed, your given throttle, the actual boost pressure generated inside the engine, and the air mass coming from the outside, because these are the various parameters which control the output, which control the working, as well as control the emission norms also. The common rail electronic control unit evaluates the signals from the boost pressure sensor, a temperature sensor, and the rail pressure also. The rail pressure helps the pump to respond for the various kinds of pressures variations. The sensors are responsible for measuring important physical quantities. The electronic control unit circulates injected fuel quantity, start of injection, duration of injection, and the rate of discharge curve, as well as supervises the correct functioning of the injection system as a whole. Now the students may have recognized the importance of ECU in an engine. It is though an electronic component in a mechanical boosted engine, but it is the most important component. Common rail injection system. The common rail fuel injection system design pre-supply pump transports the fuel from the fuel tank to the high pressure pump. An electric fuel pump is used for this purpose in the common rail fuel injection system, that is CRFIS. When the electric fuel pump is switched off, the fuel is not able to go out. This is the pre-supply pump. The electric fuel pump comprises of number 1, an electric motor. This part is the electrical component. This is the rotor, and these are the magnetic bushes. And these are the bushes. The fuel is coming from this side and it is pressurized to the outside. The fuel is coming to this side and it is pressurized to the right side. Number 2nd part, roller cell pump. The roller cell pump is kind of a rotary pump which generates the high pressure and delivers to the left side low pressure fuel to the high side fuel side. And the third important component is NRV, that is non-return valve. This is the NRV used on the right side of pump. When the fuel is in requirement goes to the right side, it is this way. But if sudden blocks occur, then this stop here. The roller cell was shown in the last slide is having this section. The roller cell driven by an electric motor. Its rotor is mounted eccentrically as shown in the left side and provided with the slots in the rotor. The fuel comes from this side and gets accumulated over here, and with the high pressure it is going through this side. The rollers are forced against the base plate by rotation and by fuel pressure. The fuel is transported to the outlet openings as shown, like this. This is the outlet opening and this is the inlet. This is a pre-supply pump. Comprised of gears. I am taking a while to giving a chance to students for analyzing the figure, because the figures that I have shown are self-explanatory. Gear type fuel pump. The drive gear, there are two types of gears inside. This is the drive gear and this is a driven gear. This is the free gear here.